Okay, now that you understand some differences between diesel and gasoline as a fuel that's derived from petroleum, we'll spend a little bit more time talking about other less conventional fuels. So the first one here is compressed natural gas, or CNG. These fuels are typically stored as pressurized gas because natural gas or methane needs to be pressurized at room temperatures or outdoor temperatures in order to be used as in a gas form in the kind of engine that's made in such a way to burn this kind of gas. Now, the reason why we might be interested in natural gas, in particular compressed natural gas, is it's a cleaner fuel. NOx is its primary emission, so a lower CO2 emissions. In fact, 25% lower carbon emissions than gasoline. Now, that's of course assuming there's no methane leakage as a result of filling the tank, as a result of storing the fuel, even as a result of drilling for it. So the methane leakage can obviously lead to additional emissions concerns. One of the drawbacks is that CNG requires large pressurized cylindrical storage vessels. So you can imagine that might be more applicable to, say, a large bus using CNG versus a small car, where trying to fit the storage vessel in might be difficult. And we think about the fact that gas takes up a lot of space, so we need that vessel to be large in order to be able to store enough to be able to go adequate distances. Also, instead of the compressed form of natural gas, we can use liquefied natural gas, but because of natural gas's properties, we have to store it at negative 260 degrees Fahrenheit in a pressurized tank to store it as a liquid and use it in the right kind of combustion engine. This too requires a large storage vessel, perhaps not as large as the compressed natural gas storage vessels, but it also has to be insulated. Keeping it at negative 260 degrees Fahrenheit is very important. And if that doesn't happen, then you can get boil off when the vehicle's not in use in particular. But liquefying the natural gas requires additional energy, and so we have to, when we think about the full life cycle costs of natural gas and of liquefied natural gas, consider that in our total energy analysis. And then the third type of less conventional fuels are biofuels. So these can be ethanol or methanol that are made from agricultural waste or farmed energy crops like corn or grain or some kind of fast-growing cellulosic material. So rather than deriving these chemicals, these parts that go into different types of gasoline, from fossil fuels, we can grow them ourselves. And one might then think of this as a renewable source because we're able to plant and grow it. But to keep in mind that the solar energy conversion process to actually take the sun's energy and convert it into this farmed energy crop is about 1% efficiency. So there's a low energy content per unit of planted area. So it's something we keep in mind when we compare these kinds of biofuels to fossil fuels. Now, there's energy that's needed to harvest and transport biofuels, typically long distances, so more than 40 miles, the transportation energy starts to exceed the energy in the harvested crop. So if we have to, again, transport these biofuels large distances greater than 40 miles, it really doesn't make sense to use them in place of petroleum products. Also, it's important to realize that these biofuels, while one might consider them renewable in some respect, they're not greenhouse gas neutral. Yes, they do absorb extra CO2 as other plants do in the environment, but they do use fossil fuels in their cultivation and their processing, and then when burned, they too can emit pollutants. So I also wanted to talk about electric vehicles. Electric vehicles are growing in the marketplace tremendously, even hybrid vehicles as well, where a gasoline engine and an electric engine are both used. They're erroneously thought of as zero-emission vehicles, meaning some people think of electric vehicles as being better for the environment, and the answer to that is, well, it depends where that electricity is coming from. As you've learned already, the electricity could come from highly polluting coal-powered power plants, or it can come from solar panels. So it really does depend on where that electricity is coming from. Now, the emissions are associated with the original production of electricity, as I mentioned, and also the batteries associated with electric vehicles can be heavy and cumbersome and expensive. And really, major breakthroughs are needed to kind of push innovations further to reduce the weight of batteries so we don't need as much energy to make our cars go, to reduce the cost of batteries, and to find certainly more ways to use electricity from renewable resources. Right now, with respect to the electric vehicles that are in the market today, typically vehicle range is a challenge and a barrier for consumers in addition to cost. The Tesla that's come out recently has a reported 300-mile range. So that's quite extensive, but requires many, many batteries and is very, very heavy. So, and of course costs much more than likely you or I can afford. So really what's on the market today that really caused innovation in the automobile market are hybrids. So these again are the combo of a gasoline and an electric engine. They use larger batteries to allow the smaller gasoline engine to operate near maximum efficiency. So it truly is an optimization problem of looking at the speed the car is going, of looking at how much braking is being used, of using the regenerative braking and optimizing the whole system so that maximum efficiency can be achieved, which is one of the reasons why the emissions from hybrid vehicles is so low. The batteries in hybrid vehicles store excess energy generated at low speeds. This is the regenerative braking, or during idling as well, and then are able to later use that stored energy to provide additional power.